That's interesting, once again.
Hey, how are
Good, how are you?
Wait, come here for the serverless meetup? Yep. You have the.
Right.
Uh,
Oh, we better get the folks from outside. Hey, folks, we're gonna get underway. Thomas, you good to go? You got your screen up?
yep. Let me find the thing to.
Yeah, you
the
can
meeting
skip
invite.
StreamYard. Yeah. Ah, you needed this.
Not this one. All right. Do you want me to join the streaming thing also?
No, it'll be
Not yet?
okay. Yeah, we'll roll without it.
Yep.
Awesome.
No, just leave it there. Yeah.
You don't have the remote slide switcher?
Nah.
You can bring up a slide or something like that, and hey, folks. Well, welcome to Serverless Sydney Meetup. Thanks so much for turning out in such great numbers. It's good to be, back in person and, getting back together, sharing a slice of pizza on a Thursday night, hearing some really good talks. And who would have thought serverless is more than just AWS Lambda? It's really good to hear from, sort of other players in the market. Hear how, we've got two really great vendors tonight. Obviously, MongoDB, round of applause to those guys for hosting us tonight. That's really good. And we're pretty ecstatic to have the CTO of Fastly here to talk about the edge being the most serverless to ever serverless. That's going to be pretty cool. So that's Tyler McMullen. And he's got a really fun background. So we'll chat about that in a second. But first, our first speaker is Tomas Arguinzones, Senior Solutions Architect at MongoDB. He's going to be taking us through MongoDB Atlas Developer Data Platform for serverless use cases. It's pretty amazing how the Atlas platform has come along in the last couple of years. So really excited actually to hear what he's got to say and take us through tonight. So without further ado, round of applause for Tomas. Thanks.
Hey guys, can you hear me? All good. Well, thanks so much for being here tonight. It's the first time we're doing one of these events after COVID, at least here. So it's very good to have you all. The whole idea is to take you through first a bit of the evolution of the MongoDB since the beginning, and then where we are now and where we're standing with the serverless platform and the developer platform too. So a bit of an agenda, MongoDB. Let's see what you guys know about it. Document model. We'll jump a bit into Atlas. That's our most recent offering. It's not that recent, actually, but the most exciting one for sure. What's our take on serverless? And finally, what's next? What's coming, right? Now, a bit of around the room. Show of hands if you've heard about MongoDB. Oh, that's not too bad. These guys on this corner don't count. So you know about the MongoDB. You heard about it. Maybe, hopefully, you play about it, and even better, you've been using it on your day-to-day for personal projects or even for your 9-to-5 work. Now, who's actually worked with MongoDB in the past since inception? Perfect. Anyone wants to share a good experience or even bad sometimes that you have with MongoDB? Is it recent? Is it being like maybe 5, 6 years ago? Maybe most recent kind of exposure you had with the platform?
I'd say pretty good documentation, pretty easy to get going.
That's good to hear. That's good to hear. Get some socks on the way out. Right. So this, and I don't expect you to read all these. We'll share the deck after we finish. It's pretty much like a bit of a evolution of MongoDB. See that starts at 3.0. Obviously, MongoDB didn't start at 3.0. Just didn't fit. But it's where we were this point and where we are now. So it's a platform that has come a long way. We've been doing a lot of interesting things. We spend a lot of money in R&D, in development. So we try to push the boundaries of all the offerings to not just be a database, as it was initially of the conception that a lot of people has. MongoDB is just a database, a NoSQL database, a document database, sometimes even like a niche database that only solves a very specific use case. That's not the case. We are a multi-purpose database, so we solve different use cases, not only the ones you might have in mind with a NoSQL use case, but also more than a database is a development platform. So once you have that data in MongoDB, what can you do with that data to having principally to avoid moving your data from a MongoDB to another system? And that's a classic kind of thing that you do with a lot of cloud platforms. We are very good partners with AWS, with Azure, but the thing that happens a lot of times is you have your data somewhere and you have to move it different places for different use cases. What we're trying to do is kind of avoid that and offer a bunch of benefits once your data is sitting in MongoDB without having to move it. So forget about ETLs or anything like that. By the way, if you have any questions, any point, just feel free. Don't have to wait until the end. Now, kind of our goal is kind of deliver a modern customer experience is relying on the underlying data infrastructure, right? So most of our modern applications have some sort of expectations that when we use an app nowadays, you expect some sort of things, right? We were using some sort of app to get some soft drinks just a few minutes ago, and the thing crashed. The kind of experience we're used to is like when I use something, I expect it to work. If I'm using Uber, I need this to work. I don't want to be stranded somewhere because Uber decided not to work, right? So it has to be highly responsive. I don't want to be waiting 20, 30 seconds for this to just come back and refresh the UI. I want this to be very quick. Also, Google kind of spoiled us with the search experience they have, and they've been provided for a lot of time, right? So we are used to that kind of experience. When I search for info, I expect relevant info to come back. I don't want necessarily, if I have a typo, I want the platform to be smart enough to show me relevant info, kind of understanding that I had a typo, ordered by relevance, but what's my search preference and that kind of stuff. So I just don't want to search data. I want data that's relevant for myself and for my use case. Mobile first. A lot of the apps that are coming nowadays are mobile first, and most importantly, mobile only. Some of the apps, like banking apps, some of the apps in the market, they don't even have a web platform. It's all mobile first, and that's where we are going. Obviously, the web is not going anywhere. It's going to stay there, but a lot of the use cases are mobile first, and that's catering for a different type of platform. Data privacy, big thing. We have, GDPR in Europe, all the different legislations for data privacy regarding healthcare, regarding PII, PCI data. Very important to cater for that, but importantly, in an easy way. I don't want this to be a pain for my developers. I want the platform to kind of help me take care of that in a way that is not necessarily I have to code it. And finally, analytics power. So cool, I'm collecting data. I'm pushing all that data from my user interface. I'm collecting all that in a very nice way, very fast, very cool. What do I do with that? Once I have that data there, how I power my analytics to actually get insights after data, right? In an easy way. Again, all this in the most easy way possible. Oh, and there was another one that I forgot, always improving, right? We cannot stay still. We have to keep improving because our competitors are not staying still. So we need to keep improving, and that comes mostly from our developers. So we all here have some sort of developer background or somehow involved in the developer community. We are very, very valuable resources for our companies, and we need to be encouraged to innovate. So we need to be have the possibility to keep always improving, pushing the boundaries. Now, when we think about a typical application, any application out there, specifically if it's one like old school, you will be surprised how many like recently built applications are still on this model. You think about, you have an application, you have multiple layers, front end, back end, all the things in the middle, but in the back, you will a lot of the time have a relational database, right? MySQL, SQL Server, Oracle, whatever you think in the middle. The problem or the thing with relational databases is whatever my data is a structure, usually it's split into multiple tables, because the concept of a relational database, you need to normalize that data so you can have the many-to-many relationships. So whatever my custom objects, my business objects look like, that's not how my data looks. My data looks different way. It's all split, it's all sparse. So I need to sometimes put an ORM. You know, you have Hibernate or whatever flavor of those you're using to actually kind of do that mapping between what my business and my objects mean and what my data relies on my database, on my persistence layer. That requires a lot of effort to maintain, to change. It's a lot of resistance to change things. It's not actually that easy to make a change and then make sure that change happens through all the layers, through all my stack, without breaking something. So that's why there's so many controls, so much time spent on actually trying to make sure whenever you change something, it's not going to break. A lot of time breaks. That also translates into time my developers or our developers are spending on non-trivial stuff, on stuff like just taking care that this is not broken instead of innovating. Now, kind of similar picture. We have an application. We have a relational database, whatever that flavor it looks like. That's usually not our full stack, right? We have a lot of the time, we might have a cache layer. We might have some sort of full text search layer also somehow involved. So our picture starts complicating a bit more. You have your database. You have to pull data out of the database, push it into some sort of other platform. Sometimes it's going to be a key value database. Sometimes it's going to be a graph database. And from there, what do? We keep pushing data somewhere else, in this case, to our search platform. And from there, we might have a sync with a mobile database because, well, we have a case for a database. We might also have an edge database. As you can see, there's just a bunch of ETLs. Each one of these little ETL blue boxes is something that can break. It's something that you have to maintain. It's something that you need to make sure it's working. So the data that my application sees is the same data that my search engine sees. If you need this in real time, it's even harder. There's always going to be some sort of delay on my data. And finally, very trendy at the moment, if you want to push into the data lake, another ETL, another sort of a sync between all these mesh of layers that you have in here. Not a very nice picture. How MongoDB, this is not new, by the way, this has been there since our inception on MongoDB, how we suggest, how would we tackle this kind of problem with our approach on the document model, and we'll discuss that quickly, and also the query API or the aggregation framework, or the Mongo query language, pretty much how we kind of query that data in a very smart way once it's inside a MongoDB database. Has anyone seen anything like this in the past? A bit smaller, a bit bigger. I've been there a few times. There's no one in that scenario that knows the whole picture. So with someone that has the domain knowledge of this corner, that corner, something changes, I have to start sometimes even printing new pages and patching that wall. It's, again, not a nice picture, and it's a mess to maintain, mostly because of all that many-to-many relationships, right? Now, on your left, you will have a very simple use case, your very simple customer kind of relationship entity model, where you have a customer table, you will have addresses, you will have phone numbers, interest, cities, countries, right? And all the relationship between them. For example, a customer might have multiple addresses. So there's a many-to-many relationship in there. Same with phone numbers. And same, that will extrapolate to a multiple thing. Now, on your right, see how this will represent, if you guys are familiar with JSON, that I imagine a lot of you are familiar with a JSON structure, how will that look? It's a self-contained object. Same way your object in your code in Java, .NET, Python, Node.js, whatever you're doing, it's a self-contained object. You will have a collection or an array inside that object that has pretty much your addresses, right? You don't have a different object. You don't have separate entity. It's all in there. It's self-contained. That's how we approach the document data model, right? We say, hey, all this data is related to a customer. Why are you splitting it? Store it all together, because when you get a customer, when you fetch a customer, you probably need the address. So why do you have to split it? Just keep it all together, self-contained in there. The benefit that gives you, this is an array. You can push, you can manipulate that array as much as you want. You can have embedded documents. So it's not only a single level. As you can hear, this is an embedded object, the geolocation of that address. And that way you can create a very complicated, if you want to, structure to kind of support your object or your business model. That is nice. That was all good. That's what MongoDB does, right? It's a database that supports or is based on the document model. Everything we store it as technically not JSON. It's called BSON. But imagine a simplified way is that structure. And that will support pretty much every single use case you have out there. That's how MongoDB started. Now, you will still have to get that installed on your server, in your laptop, in your computer, and maintain that, maintain the infrastructure, maintain the EC2 instance, the virtual machine where that was running. What MongoDB did a few years ago was release Atlas. Atlas is all the benefits of a MongoDB core database on the cloud, on a managed version. Meaning, yes, there's infrastructure behind the scenes. You don't have to worry about that. I'll show you quickly what kind of that means. Like I said, MongoDB Atlas is that managed version of the very powerful MongoDB engine on a managed flavor. What that means is you select where you want to run it, AWS, GCP, or Google Cloud, Azure, pretty much kind of aligning to whatever you're already running your application, right? If you are an AWS shop, well, that's probably what you want to run your clusters of MongoDB Atlas. But that's not a limitation. You can mix and match as much as you want. The cool thing is, and we'll see later, you can even have clusters with nodes in different providers, different regions. You can go up to 95 different regions and put data all over the world in a seamless way, in a managed way, meaning you don't have to worry about whatever infrastructure is behind the scenes. That's not your problem anymore. We take care of that. We just give you a database that you can use. All that guaranteeing security, interoperability, and a multi-cloud reach. Now, let's show you a bit of what MongoDB Atlas looks like. See what I do with this microphone in the meanwhile. So this is MongoDB Atlas. Obviously, you have to log in. Let's skip that bit. Once you're in there, you have your different projects, different clusters. I'm just going to show you quickly how you can create one and the different possibilities that you have. Pay attention to this bit here because we'll talk about it a bit later. Serverless, dedicated, and share. By default, when you select to create a cluster, like I said, you select what cloud provider you want, Azure, AWS, or GCP, depending on what's your flavor for your different applications where you're running it. Then you select a region. This is the default, by the way. This is not necessarily where you have to go. I'm going to go with Sydney because we're here. And you select a tier. This is pretty much how much processing, how much data you're going to be pushing, how much storage do you need. As you can see, it goes from the basic one and there's an M0 here that you don't see. It's a free one. The one that you can create for testing, for playing around. So you don't have to put any credit card. You just start playing with it. But from there, you can go with that until an M700 that's quite expensive for a very, very, very powerful cluster. What this will do is spin 3 nodes. So 3 little components of what we call a cluster, a replica set, to guarantee that high availability. Again, this is very simple. But what I can do is, close here. Right now, I have my 3 nodes. Again, the whole purpose of the 3 nodes is we spread those nodes in different regions. So if one of those nodes goes down because something happened, the region exploded, is the maintenance, something really happened to that, the other 2 will pick it up and your application will never go down. So that's the whole purpose of this 3-node kind of architecture. But you can also say, you know what? I also want a couple of nodes in Virginia, but I don't want them in AWS, I want them in Azure. That means the same cluster, same database, with a couple of nodes in Azure, a couple of nodes in AWS. Do the same with GCP if you want, put it in India, and you can spread your data across the world while taking care of sometimes data regulation. So this data will not leave India. This data will not leave America or Australia, depending on how you set it up. And as that, you have flexibility to add up to 50 nodes and up to 95 different regions around the world, different providers. You can also add read-only nodes if you just want to read data localized closer to where your application is living, analyticals, and a bunch of other stuff. Again, it's a bit here regarding backups. Again, it gets obviously more complex regarding security if you need more, have more strict security requirements. But what I want you to take away from here is all the flexibility that you have to first select the regions that you want your data to live, but also to mix and match and to very easy. If I go now and say, hey, I'm going to go with the basic one, 3 nodes. Save that. In a couple of minutes, my cluster is going to be up and I can start hitting with data. Tomorrow, I can come and say, hey, that 3 nodes, I don't want 3 nodes anymore. I want 5 nodes. As soon as I save, in a rolling fashion, it will start spinning the other nodes, replicating data. You don't have to do absolutely nothing. And in a few minutes, all your data is going to be replicated between the 5 nodes, 3 we had before, the 2 new ones, all across the world, all across the regions. How does that sound? I'm not going to create a cluster, so I have a few ones here to play around, but that should take a couple of minutes. Any questions so far, or do we want to leave it for the end, or do one more pizza? What do we want to do? Oh, good? Yep.
So I saw that there were options for selecting like AWS and then like Azure. So how does that ultimately make a difference here? I mean, does it enable some sort of connectivity to like
yes.
From AWS?
Oh, yeah, sorry. So what's your name again, sorry?
Sonny.
Sonny's asking, there's options for AWS and then Azure. If I start like adding nodes and different providers, different regions, how does it work internally? It literally, as soon as you spin those nodes in different regions, same region, it doesn't matter. MongoDB internally will take care of the connectivity between all those nodes, 3 nodes, 5 nodes, 50 nodes, doesn't matter. We take care of all the connectivity inter-region, if that's the case. And we also take care of like syncing the data. So whatever data you already had on your cluster on 3 nodes will already be replicated to all the new nodes to guarantee that high availability. Again, if any of those nodes go down, the other ones will pick it up and your application will see no downtime. Yep.
How does it select the right region? So if you have a web app running in Canada and Australia, does it automatically route based on some sort of logic there to the correct or the closest distance?
So good question. Your question is, if I have regions or nodes all over the world, which one, how does the routing works? Which one will I go to, right? Yep. So MongoDB is a primary, one primary, many secondaries, meaning that out of all those nodes around the world, one of them is going to be the primary, right? So you will always, by default, communicate for writes to that node, and then the replication will take care of spreading that data. But you can have data read from the secondaries if you need to.
Is that a primary for document or a primary like a primary period? Like every document has the same primary?
That is actually a good question. If it's only one primary, like globally around the world, like like it's per document. The default one we're looking at here is what we call a single shard, meaning that you might have nodes around the world, that's fine, but it's a single shard. What you can do is shard your data, meaning like there's pieces of data all around the world. And for example, for GDPR, that's what we do. Single cluster, but you say this document, the location is France. So MongoDB will take care of putting that document for residency purpose in the cluster that is set up in France. If it says America, they will route it to the other one, if that makes sense. Yes. So good question. The question is around virtual peering or VPC peering. How does it work? The connection between, if we're talking about a single provider, the connection is all internal connectivity, so private networks inside AWS, if we're talking about. From your application to the cluster, the most basic option is over the internet, TLS, and obviously there's authentication on top of that. But what we recommend is set up private networking or VPC peering. So your application will be inside the same private network that the cluster. So the traffic never leaves that private network.
Do you have any, I think that's a great idea when it comes to like the light data that's all around the world and functioning as a one application. But do you have any SLA for like 100 megabyte data to be shared the other side of the world?
Yeah, there's a lot of factors that impact that. There's like network latency, like you say, one node is here, the other node is in Canada. There's obviously a latency there that we cannot obviously avoid. There's no magic in there we can do. So what we help you is with that design, depending on what's going to be your workload, how much data per second are you going to push, and we help you design a system that will cater for whatever requirements you have. So if you have a latency of like sometimes our latency times is less than a second for a response on a query that goes all around the world, that is something we can work with you. There's not much we can do regarding network latency, but we can definitely work with the database latency. So if you have millions of records, how do we guarantee that when we do a search, you find that record that you need in milliseconds response time, if that makes sense. Sorry,
for example, I remember when they were building some data center, they were having the limitation of having the 600 miles of distance to having another data center. Otherwise, it's taking too long to having the same transaction.
We don't have those like distance limitations. again, it's more, we will, if it's a write transaction, we will commit the transaction, we'll guarantee that the transaction is committed. But if it's a read you're talking about, then there are things like the network latency that depends on the region, depends the distance, and there are, again, things that we cannot necessarily avoid. But then there are other factors that we do have influence, and that's how, for example, how we spread your data, what kind of cluster are we talking about, what size of the cluster, and that kind of stuff, if that makes sense. So it's a combination of different factors, yeah.
Are there limits to reads and writes of the Atlas product?
No, it depends. Again, ideally what we do is we help you design based on your requirements. We help you select what kind of tier will you go, but there's no limits on reads and writes per se. Yep. All right, wait. So there's a couple of more slides that I have to go. So this is good. I mean, all that we just saw. Hopefully, like you find it interesting. But at the end of the day, there's still an underneath tier you're selecting, like where my data is going to live, right? Like we call it like M10, M20, M30. So how do we, what's our take on actually serverless? I don't care how much you're provisioning underneath. I just want to push data, and you will provision that for me or cater for that volume of transactions. So my application stays up no matter what. That works very well when we don't know our workloads. That works very well if our traffic is very variable. So sometimes I have millions of transactions. The next day I have only 10 transactions. So that works very well. It's a bit more, as you guys probably experience, it's a bit more, when you go into that model, it's a bit more expensive to pay for that, like the provision model. But it is there to cater for those requirements where, again, I don't know, a lot of time, I don't want to over provision, or I don't want to pay for a cluster that sometimes is just there sitting doing nothing because my traffic didn't hit that threshold then, right? I'm going to just skip through a couple of. So again, serverless solves many pains. Application demand is not always predictable. Sometimes it's a lot, sometimes it's not much. Over provisioning, and this is a common use case we see, especially on-prem, is very common. In the cloud, still happens. You have to provision for your highest peak because you don't know when that peak will hit. And managing infrastructure, no one wants to care about like spinning on an EC2, handling the security, patching that EC2 instance. It's just not necessarily an exciting job. So you want to care about innovating and designing new technology. So we do have an Atlas serverless instance. It's the same technology we're talking about. You don't have to specify a tier. You say, where do you want it? And we take care of pretty much taking all that workload, all that traffic. We scale up and we scale down. It's a very new offering. We just released it in GA a couple of months ago. So it still has a lot of features to catch up compared with the dedicated clusters, but they're there if you need to. You have that kind of workload where you really don't know what the traffic looks like. And this is, again, our take on the serverless app or developer data platform. You put your data in MongoDB, flexible, dynamic schema, high availability, scale up, scale horizontally, all that is there. But once you have your data, what do you do with your data? As you can see here, it's quite small, but then you have your transactional workloads, obviously, but then also you can have search. If you guys are familiar with Elasticsearch, Solar, it's pretty much all based on Apache Lucene. What we did is we built an Apache Lucene index on top of MongoDB. So you can build up your full text search, querying already directly data that you have on MongoDB. You don't have to move it from here to your Elastic. You leave it there, and you just query. So it's super simple, super easy to run. Again, you don't have to ETL, and that's already a big win. Same with analytical workloads. You can just query your data with analytical nodes. We have a lot of analytical capabilities. Just query real-time data. You don't have to query ETL. You don't have to ETL your data or query stale data from a day old or something like that. We have a mobile application or what we call a realm that pretty much takes care of syncing your offline applications, your mobile app, whatever data you have in there, takes care of syncing it with your MongoDB cluster and conflict resolution. If your mobile application goes down, goes offline, there's no signal, all that is automatically taken care by our realm platform. All that with the baseline of secure, multi-cloud, and resilient and elastic. There's another demo, but I don't think we have the time. So what I'll do is I'll share the deck when we finish, and then I'll share some GitHub repo, so if you guys want to try. Again, feel free to spin M0. It's like a free cluster in MongoDB, mongodb.com, create an account. Free cluster, you can play around without paying anything. Also, if you get some socks, there's some codes in there. I think it's $100, not sure, but you should be able to play a bit longer with that.
Round of applause for Tomas. That was really awesome. Really appreciate that run through, Tomas. There's always so much to showcase in a Meetup talk. We're going to dive straight into Tyler McMullen's talk straight away, but it'll probably take him a minute or two to set up his laptop. So feel free to grab another drink and a slice of pizza while he's doing that. And I'll tell you a fun fact about Tyler. He wanted to be a professional skateboarder, but CTO of Fastly was a reasonable runner-up. So that's pretty cool, isn't it? And anything that you're sort of like listening to tonight, if you get inspired to build something cool, or you're doing something with like Mongo or Fastly in your day-to-day job, then very interested to sort of hear from you at a future meetup. Potentially you can come along and present. So yeah, reach out. Cool. How's your laptop going? Is it all set up? Okay, yeah. Cool.
Can I ask you a question? Very nice person. I'm curious about infrastructure as a code.
Yep.
Oh, okay. I'll ask the team.
Questions?
Yeah. I was just going to hook you up with a lapel mic, and then you might need this for the room.
What you can say, spin a cluster, delete the cluster, scale up the cluster, right?
Through CLI.
To CLI, so like so REST API.
Cool. I think that just clips onto your t-shirt, and you can whack that in your pocket. Yep. Should be all good.
Clicker?
No, I don't need a clicker. I'll just walk over and hit the button. It's fine.
Thanks so much.
Yeah.
You ready to go, or?
Need just a minute to set it up.
Sure thing.
Nice intro.
Thanks for that one. That's pretty cool.
I actually haven't been to Serverless Meetup. How is it the
Yeah, kind of. This occasionally, like it's in where we're located. It's just a couple of, like we just kind of move around. So so sometimes when you're right above a train station, you get a bit more of a walking towards sort of Chinatown. It's just a little bit of so. It's a bit like that. We just kind of need to get back into that regular cadence, and you slowly build up and stuff like that. Oh no, we've had probably this is the fourth or something like that. It's just been a bit, excuse me, sporadic or whatever. So like I think once we sort of start getting into that rhythm, it'll like the crowds will start coming back. I think if you look at any meetup across Sydney, they're kind of like 50% down on pre-COVID.
Another one 2 weeks ago, I think, talking about video text.
Yeah.
Yeah, that one was in Microsoft's office.
Oh, yeah, I heard about that one.
Yeah, that was fun.
Pumping crowd, was it? Yeah, all right.
80, 70, 80 people.
Yeah, I heard that. That's amazing.
I think we only sent the invitation out yesterday. So like, maybe next time.
Yeah, if we just kind of help
But
promote.
no sales pitch from us. It's gonna be interesting.
Oh yeah, no, that's really appreciate you organizing it. Yeah. Thank you so much. Really appreciate it.
Nice to see you.
Yeah, likewise. Thanks. So, cool. I guess you want us to kill the lights now, or?
Oh, I mean, it's totally up to you. Like, I can also just signal it for like that slide.
Yeah. He's got a slide where he wouldn't mind us killing the lights.
Yeah, it's just gonna be hard to see otherwise. Oh, fair enough. If not, no worries.
Yeah.
No biggie. Yeah. There's just like one nap slide with the black background that it's.
Oh, okay, yeah.
It's gonna be real hard to see.
If it's our AV guys left for the day, it's probably going to
Cool. Awesome. Thank
See
you.
what we can do. Cool. So you still skateboard much these days, or you?
Not as much, mostly just for getting around San Francisco. Like I used to skateboard to work every day, but
right.
Yeah, it's great.
So you like live in the city, or?
Yeah, in the city proper. Yeah.
Yeah, right. Nice. Yeah, I was just there a month or two ago for like Data and AI Summit for Databricks.
Yeah,
It's pretty cool.
Nice.
It's definitely got a bit of a buzz going on over there, doesn't it? Did that work?
I mean, the funny thing is, it's actually this light that's a problem.
There it is. All right.
If the answer is no, it's totally fine. No worries.
Oh. How good's your voice? This mic's not looking good.
Yeah.
Might
That'll work.
Stuck to the.
Yeah, makes sense.
Want me to be
Nah, it's all right. I'll work it out.
All right. We might just get straight underway. Tyler, would you like to take it away?
Sure. Why not?
Awesome. Round of applause for Tyler. You
I
like
see.
okay,
There's
beer
two
and
mics.
laptop and microphone.
I see. There's two microphones. Got it. Hi, everybody.
Yeah,
So-
he's got it. So
So I think you mentioned earlier, like, this probably be a couple like product pitchy sorts of talks tonight. So if you are expecting that and looking forward to that, you are about to be disappointed because I don't know how to give a product pitch. This is instead, as you can tell, just kind of like a weird meandering down the jet lagged crevices of my brain. So that's what we're going to do tonight, just real briefly. Hi, I'm Tyler McMullen. I'm the CTO and co-founder of Fastly. And I spent the last 6 years working on our edge-based serverless platform. So that is like kind of been my like life and everything for the past 6 years. We'll get into that a little bit. I mentioned I work for Fastly. Fastly, if you don't know, is it's a giant edge network, right? We have actually I'll get into that, but like we have POPs all over the world, including here in this very city and basically most other cities in Australia. We do CDN, which is the main thing that we were known for years. We also do security things, and we do edge computing. And today I'm going to talk about that edge computing side of it. So let's talk about something complicated to start with. Seems like a fun way to start a talk. What's it actually like to run an edge network, right? I mentioned that we have POPs all over the place, like Hawaii. We're in Perth. We're in Adelaide. We're in 3 places in New Zealand. We're in multiple places in Africa. We're all over India. It's real interesting. Let's talk about it. So first of all, like when I say that we're in all these places, I don't mean that we're in the cloud in all these places. I mean, I literally have servers in buildings in all of these places, right? And these are actually like 4 of our racks. That is about 64 servers. Each of them has approximately 1 terabyte of RAM in them. I can't even count the number of petabytes of storage in each of them. Yeah, and so making the most of these servers is actually like one of the hardest parts of like running an edge network like this, just to start with, right? One of these servers can at this point push about, like on a good day, 400 gigabits per second by itself. And so, do the math there. We're talking about like multi-terabit level, like individual data centers in like 2, 3, 4 racks. So, right, mentioned we're in a bunch of locations, thousands of servers across the world, which if you run large networks, if you run large data centers, the more servers is more problems, much like many things in life. Multiple different hardware architectures. So, right, when we start to talk about all right, so the purpose of an edge network, there's a bunch of purposes for an edge network, but one of the main purposes is resilience. The other one is like mainly performance. But when we start talking about like the number of nines of resilience that we're looking for in this sort of setup, 2 nines, 3 nines, 4 nines, you can get that with software a lot of the time, just like intelligent software design and like how you design your distributed systems. But when you're getting to like 4, 5, 6 nines, you're actually starting to worry about things like hardware architectures, right? Like I can't have the same hardware in every location, because on the off chance that there is a failure that there's a 0 day in some SSD that like takes down every server simultaneously, that's like, I can't tolerate that sort of risk, right? So in addition to just the fact that it takes time to roll out new servers, we actually intentionally have multiple different kinds of servers, multiple different types of hardware in different locations around the world. And then there's transits and peering and interconnects and things that most software developers don't want to think about, like the actual nuts and bolts of how the internet actually works, right? So you have top tier transit providers, the level 3s, of the world, for instance, the Telstra is in quite a few places as well. Then you start to worry about peering, both for being able to reduce costs as well as to actually improve performance. And there's interconnects, so you don't want to have to go through transit to be able to talk to AWS. Anyway, it's a lot of stuff, right? And when you get into that stuff, you start to see that running an edge network actually has a lot more to do. There are technical problems like what we have been talking about already, but then there's also geographical problems and geopolitical problems. So for instance, yeah. Oh, right. So, right. That's actually a totally valid question. There's a lot of confusion in the market right now about what the edge is. And I would like to fight all the telcos. So what I'm talking about with an edge network is basically just a network that is spread across the entire world. Our goal is typically to be within 30, 40, 50 milliseconds of every single human in the world, right? And so from here, you probably get about 10 milliseconds. Sorry, say again? Yep, basically. People buy our computers. That is, yes, people give us money to use our computers in various different ways, yes. In essence, in a way, yeah. I think that our approach to it is quite a bit different, but yes, indeed, fair enough. Yeah. Yeah, again, over 100 locations. And right, so at this point, we start to think about things that that are geographic sorts of problems. So for instance, you might not know this, in some locations, things tend to go missing. There are some places in the world where you ship a pallet of servers, and you should expect that half of those servers are going to fall off the back of a truck along the way, right? So things that we don't typically have to think about. There are some locations where you have to deal with local monopolies. There are some countries in the world where there is literally only one ISP. In order to get access to that area, you have to pay whatever that one ISP is going to charge you, right? And then there's the politics of the networks themselves. So this is the one, this is the slide that I was trying to get the lights turned off for because it's actually kind of hard to see. So this is going to take a couple minutes, so bear with me. But this is actually a shockingly interesting map to me. So what we're looking at here is actually from a few years ago. And what we did is we sampled, over the course of weeks, we sampled traffic from like every single connection that came into our entire network, right? And we plotted them on what was a black field. First of all, there is actually no map here. This is simply like dots drawn on a black field based on their latitude and longitude, which is kind of cool by itself. And we plotted them from cool to warm based on how the latency was for those connections. So the cooler it is, faster the latency, warmer it is, worse the latency. And so you can see some interesting things in here. So like, first of all, the part that is washed out there, that is Australia. And so what you can see is like for the vast majority of people in Australia, we actually have like really good performance. And that's kind of what you would expect because like there's good networks here. There are like major population centers and like we can serve Australia really well overall, right? Up here, you can like, if you look at the US and you look at like Europe, you can see some interesting things. You can actually kind of start to pick out exactly where our pops are, right? Just based on like the gradation of blue to like a green sort of thing here, right? And so that's how you kind of expect it to look. Then there's other parts of the world that get real weird and interesting. So for instance, I would point out South Korea is an island on this map. That's because according to the internet, for the most part, North Korea doesn't exist. And so we just don't have data points for it. You can also see places where countries simply do not route traffic over their borders. So for instance, there is a spot of blue here surrounded by red, right? And that's simply because there are no network connections. And so in order to serve those places well, we would need data centers that are literally miles apart from each other on one side of a border or the other. That's kind of crazy, right? In fact, there are some places where it's even worse than that. So, you know, you probably saw on the previous slides, we had a bunch of locations in India. So if you take a look at India, India is really interesting. Not only does, you know, are there issues routing across borders from one country to another, but in some places, they don't even route across states. So that's actually what's happening here in India. Like each individual state frequently has their own ISP, and those ISPs don't connect to each other, right? And so you can have, again, like red spots right next to blue spots. So, you know, these are some of the interesting things that I find about running an edge network that I think most people don't really realize when we start talking about these things. So, okay, edge networks are complicated, fine. Let's talk about something simple. The slide that everybody has. What is serverless? Super simple, right? Like that's the whole point of serverless. It's supposed to be super simple, right? So I guess I should note, I'm going to talk about something like a specific form of serverless which is like functions as a service, right? And so I'm just going to use that as a general example here. So let's talk about the history of this, right? In the beginning, you had a server. Everybody knows that's what a server looks like. Looks like an iMac. Everybody knows, yeah, right? Okay, you know, it's fine. And then after we, you know, had just had servers, someone invented the idea of the virtual machine, which is a server inside of a server, right? I mean, ultimately, that's actually what it is, right? When you look at like VMware, VirtualBox, all those sorts of things, they're just actually emulating the hardware, right? Or at least that's what they're trying to do. All right, so fine, we can't fit that many servers inside of our server, so let's see what else can we do. What if we try to fit a whole bunch of Linuxes into our server? And that's containers. That's ultimately what it is, right? VMs are trying to emulate the hardware. Containers are trying to emulate the operating system. It's giving you separated operating systems effectively, right? And then a thing happened, and like, you know, you might argue with this particular telling of history. I think this is the correct telling of history. There was a thing that came along called V8. Wait, not that V8, sorry. That V8, that's right. I would argue that this is actually the thing that came along that made like serverless stuff possible, at least like made it easy to do and made it like, was kind of the start of it in a lot of ways, right? And that was because V8 was solid, right? Like it was built into Chrome, it was fast, it had like a pretty easy like embedding profile. You could just stick it in the server, call it good. Like lots of our competitors, as well as like other folks in the industry, they basically just took a server, jammed V8 into the side of it, and bam, you got a serverless platform. Off you go, right? That's fine, right? So like use V8, you get a whole bunch more, right? You could only fit a few servers in your server. You could only fit like a few more containers in your server. You could fit a whole bunch of V8s into your server though, right? And that's cool. That increases your efficiency, right? There are some like downsides of this though. So V8 is fast, but it's actually not fast enough, in my opinion. And one of the ways that you can see this is that when you look at the way that these things actually work, you have like a user comes along and they say like, hi, I want to run the code for this particular site, or I want to like trigger an event for this particular thing. And the server goes, okay, cool. I don't have that running yet. I'll start a V8. Great. And off it goes. The next user comes along and it goes, hey, cool. I already have one of these. I'll just reuse the same one. Great. Cool. Next person comes along, same sort of deal, right? And like, that's fine. And that's efficient. It does have downsides though. It means that you are drawing the security boundary around the program, not around the end user. And so this is a really good model if you're trying to protect like your infrastructure from your users, but not if you're trying to protect your users from each other, right? And so, you know, again, like, you know, this is 6 years ago at Fastly, but I looked at like, you know, doing this sort of thing and I was like, that's not actually good enough for us. Like we have a bunch of customers who are like, you know, do a lot of like very privacy conscious things, right? Like if you have banks as customers, for instance, like, you know, the risk of accidentally like leaking information from one user to another is like kind of not a thing that you want to tolerate, right? And so we're like, ah, crap. Okay, so that's not going to work. What else can we do? Well, before I get to that, I'll say, I actually think this problem is way worse than just that. And that is because a function as a service is not just a function. This is, I think, from a few years ago, but it's a dependency graph of NPM, right? And so when you're talking about like a function, we're talking about a function as a service way, like we tend to think about it as just like, oh, cool, it's a function. But it's not just a function, is it, right? Like, you know, the fact that we have NPM now and Ruby gems and PyPy and all of these sort of registries is really cool and like has increased our productivity like tremendously. It's incredibly valuable as engineers, but like, where is all that code coming from? Like we kind of, I mean, I put import left pad in there for a reason, right? Like anyone who's around for that will know what I'm talking about, right? So yeah, so like, right, not only are you like, you know, making the security boundary around your program, but you're also including all sorts of things that you don't necessarily know or trust, right? And that is a much harder problem to solve as it turns out, right? But okay, so like 6 years ago, again, I started working on this problem at Fastly. And we're like, all right, what can we do? What'll like work better than this? So our model looks a little bit different. It looks a little bit more like this. So a user comes along and we say, okay, cool, we're gonna spin up your function. Great, that's, I mean, like ideally this is like the way everything would work in my opinion. And we'll spin up a separate function for the next user. We'll spin up a separate function for the next user. And the way that we do all that is because of our use of WebAssembly, right? So, you know, 6 years ago, again, like we started working on this project and I was like, cool, I think this WebAssembly thing that is just starting to come out might actually be the solution to our problems, but it's really young. There are no server-side compilers for it yet. There are like very few languages that support it, but I think this might be the future. Like I'm gonna bet on this thing. And so what we did was we went off and partnered with some friends at Mozilla and we wrote a compiler from scratch. That compiler is called Wasmtime, uses something called Crane Lift. And so like all written in Rust. So like we actually have a decent amount of confidence in the safety of this program. And the really cool part about it is that you can spin up a WebAssembly sandbox in about 15 microseconds, which means it's fast enough for us to spin up an entire program for every individual request that comes into the system. So every individual request gets its own sandbox, right? So that's cool, but that doesn't actually solve the second problem we were talking about, right? It totally doesn't address that thing. So like if you've seen any of my talks in the past, like actually I guess like I should mention this is the first talk I've given in person in like 3 years, which is wild to me because I used to do it like every week basically. It's crazy. So right, I've been talking about this thing for years, but like over the past couple of years, we started working on something else inside of this. So I assume everyone here is like at least somewhat familiar with WebAssembly. Yeah. So is anyone here familiar with something called the WebAssembly component model? Yeah, good, great. So the WebAssembly component model is in the alpha stages in the standardization process at the moment. And the idea with like the easiest way to describe this is that So with WebAssembly, you had a module to start with. You can take that module, you compile everything in your program into this one module, and off you go. WebAssembly components are a new thing that is like a wrapper around a module that is supposed to make it so that you can link it with other modules, which may be in the same language, which may be in different languages, and taking advantage of the fact that we can spin up one of these sandboxes in about 15 microseconds. It means that what we can actually do is take your program and take its dependencies and sandbox the dependencies as well. And that does start to require like some changes to the programming model, which is like a little bit difficult to work around. But like, you know, so basically the idea is, you know, if we go back to like the left pad example, why did left pad have access to the network at all? Why would it ever need access to the network? All it ever needed was the access to the string that you gave it and to give you a string back, right? And so that's the idea with the WebAssembly component model, is that basically it uses something called capabilities, right? And so the idea is that when you spin up one of these sandboxes, it has exactly 0 capabilities. It has nothing. It can do nothing. It cannot access the system in any way. And the only thing it can do is use the capabilities that your main program gives to it. And that's the idea. And if we can make these sandboxes fast enough, it means that we can actually do this kind of thing, which is, I think, would be like a pretty big deal, honestly. Like it's a, not to mention like the linking between programming languages. That part is really cool. So in order to accomplish this, we started working with, again, Mozilla, Intel, Red Hat, Microsoft, a bunch of folks. We created something called the Bytecode Alliance, which is a group of companies and a group of people from those companies that are working on the WebAssembly tooling and the standards around WebAssembly, not the WebAssembly core itself. But one of our first things was working on this like component model. And so multiple different languages are starting to support that now. I think Rust is first, C and C++ will come next, and we'll see what happens after that. I think JavaScript is coming after that. So speaking of JavaScript, I remember a few years ago, I was like, we're gonna run JavaScript on top of WebAssembly. And people looked at me like I was crazy, because like WebAssembly runs in JavaScript, not the other way around, right? Like, why would you? Yeah, and so that's what we did. So we actually have like a reasonably fast JavaScript implementation running on top of WebAssembly at this point, which means we could sandbox JavaScript the same way we can sandbox C code or Rust code or any other kind of code, right? And speaking of that, a lot more languages are starting to support WebAssembly these days. So we actually have .NET that is working pretty well at this point, which is like wild, right? Who would have thought? And the list keeps going. They're actually pretty good. So, all right, let me like wrap this up and talk about like why this is, why I talked about these two different things. So from my perspective, when you combine a super complex edge network and serverless, which is supposed to be simple on the outside, but if you look at like the internals of what you're actually trying to do is also super complex, you end up with a system that is like internally like more and more and more complex as it goes along, right? Thousands of networks, thousands of servers, hundreds of locations, custom Linux kernels, compilers built from scratch, entirely new languages and protocols designed from scratch in order to make this thing work, right? And so here's the deal. Here's like my ultimate goal with all of this was to be able to take a function and make it scale globally and for you to not have to think about it, right? And like all of the work and all the complexity that goes into that is like ultimately the reason why I think that the edge is going to be and like will continue to be the most serverless to ever serverless. It's because it has to be. Because if you expose this level of complexity to users, nobody would use it. It would be completely unusable. So in order for it to like actually work, in order for the edge to be what like I think we hope that it will be, it has to be serverless. There's no other path that makes sense. So that's my talk. Thank you.
Any questions at all? I'll just throw you seem like an expert at WebAssembly. So what I know WebAssembly sort of JavaScript has been our WebAssembly, but it's pretty bad WebAssembly because it's designed as a unified language and not really use it like that now.
Sure.
But so you mentioned one benefit of WebAssembly is this container sort of security format.
Sure.
Any other? What are the other big benefits of WebAssembly?
So the question was like, what are the big benefits of WebAssembly over JavaScript? I don't think it's like actually I don't think that that's a like reasonable comparison. You're comparing apples and oranges there. Like JavaScript is a language, WebAssembly is a like target, right? WebAssembly is the equivalent of saying like x86, right? No, I agree, right? That's fair. I mean, the advantage then is like it can be compiled to be smaller and faster. That's really ultimately it. And also all the security things, which like you probably do that with JavaScript as well, but like no one is, and there's a reason why, and that's because it would be super hard. Yeah. So yeah, that's all I got for that. True. Yeah, no, it's a super valid question. The answer is it's like that's where our customers are at the moment. Like I would love to fix that because it sucks and I hate showing that map for that exact reason. Thank you for calling it out. It's actually not there that I was talking about. I don't want to break any relationships, so like I'm not going to say where. Oh, good. Any other questions?
What is the state of things?
What is the state of things?
It makes me like you're in transition or something.
No, I mean, definitely not.
Come buy our stuff.
Oh, yeah, come buy our stuff. And that is a product called Computed Edge. It's an edge computing platform. It's a functions as a service request response model. I talk about things, sorry, I should explain. Like I talk about things as if they're in transition because that's like kind of my job, right? Like I'm always thinking about like what's coming in a few years. So like most of the stuff that I talked about here is actually already available except for like some bits of the component model, but like I'm not satisfied with that. So like we're working on a bunch of new stuff as well. We'll talk about like new execution models and new like triggering systems and new languages and so on. Yeah.
Do you see like, you know, at the edge, full applications being capable of run, you know, not to create a war between yourselves and MongoDB, but like some of the capability that MongoDB talked about today, can you see that actually happening at the edge or?
Yeah. I would love to get to the point, and you can't do this yet, I would love to get to the point where you could actually just run databases straight up at the edge. There are super like weird complications with that. Like most databases are not meant to scale across hundreds of locations and thousands of servers simultaneously. That said, like there are things that we could do and say like, all right, well, what if we just capture this, oh, what's the best way to put this? Essentially capture the data into like a single pop or into a single region. And then like you have different consistency models as you like start to scale out from there, right? So like, you know, at a global scale, you're probably not doing like strong consistency in transactions. Instead, you're doing like CRDTs and eventual consistency or something like that. But like in answer to the original question of like, do I see full on applications running at the edge? Like, yeah, I think so. Not everything makes sense to run there. I think one of the neat things about running a global network is that we kind of get some visibility into which things make sense to run at the edge and which things like need direct access to, say, for instance, like a MySQL database that is running in one place. And like my view of this is eventually we'll get to the point where we are actually taking applications and being able to spread them across the network. And so like run the parts that make sense at the edge and the parts that don't make sense at the core.
Very
That's what I'm hoping
interesting.
for. I don't know.
Cool. No more questions? Round of applause. I'll just grab the microphone real quick. Well, it's not every day we get CTOs of CDNs coming to visit the Serverless Meetup, but we're sure happy to have him here. But yeah, like you, basically this community is really about you. So what would be interesting at the next meetup when we get around to it is just to see what you've been up to, like building out your applications, you know, in your various workplaces and stuff like that, using a bit of MongoDB, bit of Fastly, bit of something else. You know, what are your war stories? You know, has it worked out really well? Have you ever had a few struggles with whatever you've been building out? You know, that's really how we learn and grow. It's great to see what the latest and greatest is tonight, but it's also just cool to share all of our patterns and stuff like that. So thanks so much for turning out tonight. I really appreciate it. I know a lot of us are working from home. I'm like 100% work from home these days. So coming into the city is a bit of a novelty for me. But yeah, so really appreciate it, and see you next month. Thank you. Oh, and thanks so much, MongoDB. I think there's heaps of pizzas. Stick around for a bit of networking, and then we'll head off in about half an hour or so. So awesome. Cheers. Bye. Thanks once again. Yeah, really great. Great to meet you. Yeah, apologies. Oh, I'll turn off the live stream.
Hey, thank you. That's fun.
Sorry, buddy.